Hi, I'm Bob.
Hi, I'm Daniel.
And hello, I'm Rachel.
The goal of this project was to transmit and recover an image over an audio channel between two handheld radios. We were given 75 seconds of transmission time and limited by the bandwidth of the radios, which is about 3 kilohertz.
Leading up to the project, we completed several labs to set up some preliminary pieces of a transmission scheme, including an APRS transceiver, an AX25 packet layer, and an AFSK 1200 modem. This gave us a baseline 1200 baud rate transceiver. With 75 seconds of transmission time, this translated to approximately 11 kilobytes of transmitted data.
To transmit larger images, we applied compression as well as made modifications to the transmission scheme and channel. The ultimate metric of transmission quality was calculated using a formula for PSNR between the original image and the recovered image. The receiver.
And I am the transmitter. Ready?
Yes, okay. And I've started the queue, so you can start transmitting packets now.
And now we are transmitting packets, as you can hear from our third radio over there.
So right here we have the radio that's actually performing.
As part of our project, we implemented adaptive downsampling and upsampling to decrease the size of the image to be transmitted within the allotted time, which turned out to be about 7 kilobytes. We also implemented naive quantization, where we bucketed the color values, and on the receiver side, we applied linear interpolation to smooth the image.
Separately, we implemented JPEG. The algorithm first transformed data from the RGB space to luminance-chrominance space, then split data into 8x8 blocks, and took the blockwise DCT. Finally, the algorithm used a quantization matrix to throw out sparse coefficients. Although we started with an APRS implementation to transmit raw image data, we eventually pared down the packets to remove superfluous information, such as destination and digipeater fields, and just used the pure AX25 protocol in order to make data transfer more efficient.
Finally, just before transmission, we used tarball entropy compression to compress the image data as well as some metadata for recovery.
We were successful in implementing the JPEG protocol and code. However, after running the file through entropy encoding, our implementation was not efficient enough to meaningfully compress the data. In the future, this probably could be fixed by improving our quantization scheme to throw out more coefficients.
We also attempted to increase the baud rate to 2000 by changing the mark and space frequencies. However, while we were able to achieve this in loopback, we were not able to implement it over the air. Separately, we also tried implementing a scheme that transmitted over 4 different frequencies instead of just 2. However, we ran into issues with filter sharpness limiting high fidelity between frequencies.
And let's go ahead and unzip the file. So what we've just received is a tarball of all of our data. So then we will use each of the separate files to recover the data. Oh look, what's that?
I see the MRI.
So this is our image as we downsampled it. And now we are going to proceed with upsampling with factors that were also transmitted, as well as perform some simple interpolation.
Okay, so the interpolation took a little bit of time. And this is the image that we received after the interpolation. Okay, and we can calculate the PSNR. Looks like a hearty 25.8. Here are the PSNR values for the 5 images we tested with. Here are the PSNR values for the 2 images we demoed with. Thanks for watching.
We'll see you next year.
Goodbye.